Today we're going to be looking at the earth science and the system, the scope of earth science, doing science, and science and society. Rachel Carson, a marine biologist, said, "The materials of science are the materials of life itself." Science is part of the reality of living. It is the what, the how, and the why of everything in our experience. It is impossible to understand man without understanding his environment and the forces that have molded him physically and mentally. The aim of science is to discover truth. Scientists want to identify and measure the natural processes in order to understand them and to monitor the variable over time to predict future trends to help society. One example of how scientists seek to help society is by measuring the sea levels over time. Earth science really encompasses a lot of different types of science. The investigation of interactions among the four components of the Earth system. The atmosphere is air and the weather. The hydrosphere, hydro meaning water, includes liquid water and ice and water vapor. The biosphere, bio meaning life, the plants and animals, and the geosphere, geo meaning earth, and the interaction with the exosphere. You really couldn't isolate one from any of the others. So what is science itself? Science is a process of discovery and research to find out the unknown. So much of it is still unknown, which gives scientists this drive of curiosity and creativity to discover answers that aren't known yet. The unknown has driven humans for thousands of years. Science is not a list of facts to be memorized. That is very important. That's why there are no tests. We're covering so much in this course, all the way from the beginning of the universe through climate change. And that's an unimaginable range of time. And it's just as massive an amount of information to remember if you were trying to memorize every single detail or fact. Don't try to memorize science. It's not the nature of science. Take in the information, absorb it, and then use that information to analyze and to make decisions. Later on, you can apply your knowledge to situations that occur. Scientists collect data, and they use that data to make decisions. Well, how do they collect their data? Direct measurements, indirect information, and modeling. Direct measurement is when they directly use an instrument to collect information, such as these technicians here in the picture. They're using a lot of different bottles to collect ocean water samples. This is direct measurement. This is a model. It's a wave tank. It's used to simulate tsunami waves generated by earthquakes. Modeling. Here's a real-life example of scientists actually doing science. In a little town in Kansas called Hutchinson, there have been some gas explosions going on. And they're trying to figure out where exactly the gas is coming from, how it's getting there to explode in the first place. They're using their best knowledge to try and figure it out. And you can see there's a brown layer, and then a sort of thin tan layer, and then there's a rubble layer, which is a coating systems used by geologists to say that this is a dolomite layer. The first hypothesis was that the gas traveled through the porous rubble layer and then it escaped from the wells to the surface, where it exploded. That's a good hypothesis, but that's not what was happening. They drilled a couple of test drills into the layer of rubble rock to see if they could locate examples of gas. And there was no gas in the rubble layer, which meant that their hypothesis was incorrect. What they discovered was, as they drilled down through the dolomite, they found cracks through which the gas was traveling. So since dolomite was really solid, they had to think about how it was getting through there. It was the fractures and the breaks within the rock that allowed the gas to travel through. And that information they used to make another hypothesis, and then they test it. In the process, they found additional pockets of gas which would prove to be very hazardous in the future. And they also found a lot of information. But they accepted what the facts and the evidence showed them. They were able to change their initial hypothesis because they didn't find any gas in the rubble. They were able to change it, think of something else that it could be, because the evidence showed that their hypothesis was incorrect. A hypothesis is something that evolves. As more evidence is collected, it just changes. It's not something that someone decides on and sets it in stone and says, okay, we're going to prove this now. It's something that morphs as you find further evidence or experiments that change the original idea. And you need more than one prediction based on a hypothesis. The hypothesis is a testable explanation that can be verified or determined incorrect depending on the information that comes back. Scientists do actually follow some basic rules, very basic and very loosely. A scientific hypothesis is tentative, and obviously it can change, as shown from the Hutchinson example. A scientific hypothesis should be predictable and testable, and the test results should either support or falsify the hypothesis. It's not something that's just made up. The hypothesis is actually based on data from empirical, which is based on experience, observations, or experiments. The scientists don't just create a hypothesis based on nothing. It is based on actual data or observations. The hypothesis offers a well-defined natural cause to explain a natural event. That's science. And that's how scientists do science. As far as the scientific method goes, it's not necessarily followed in order by scientists. Not all science is good science. It can be of particular concern when you read about science reported in the media or even in the movies. Believe it or not, the movies aren't always correct. Think about the movie Armageddon. There's a lot of bad science shown in that particular movie. Common pitfalls of science. Attacking the scientist rather than the science. It's not uncommon when religious views conflict with science. Think about Copernicus or Galileo. What happened to them when they were talking about the sun actually being the center of our universe? Look it up. See what happened to them. It's quite interesting. Also, things that happen when politics conflict with science. What are the responsibilities of scientists to society? The earth scientist's role is to alert people to earth processes or hazards that might cause damage or loss of life. Think about flooding or a hurricane or a volcano. They also provide for the material needs of society by managing the natural resources. They protect us from activities that might endanger the natural environment and ensure the future of humanity from global threats such as climate change or an asteroid impact. Well, which types of natural hazards are the most significant for the region where you live? Earthquakes, volcanic eruptions, hurricanes, tornadoes, landslides. The Earth scientists' role to alert people to the processes or the hazards to prevent these things from happening, the prevention of flooding, or to adjust. An example would be building code regulations. That's an adjustment. In providing materials for the needs of society, renewable resources and non-renewable resources for energy, to create a sustainable society that satisfies the need for resources without jeopardizing the needs of future generations. What happens when the resources run out?